Hello there. So we're going to talk about geometric vectors and how to do a bunch of stuff with them. The first thing I want to talk about is what a vector is and the notation for them. The vectors are usually we use lowercase letters with them, like a V or an R, and a half an arrow. So that's the notation for a vector. And vectors have magnitude, which is their length, and they have direction, and almost always their direction is an angle measure. So when we talk about a vector, we say, okay, it starts here, it's that long, and it goes that way. And by that way, we mean, let's say if you were to measure it from the positive x-axis in the coordinate system, how far would you have to rotate to get to it? So that's the direction part. The magnitude part is how far is it from there to there. And I want to give some language that'll help a little bit later. This is called the tip. This is called the tail. So that's some language that I'm going to be using to help you out here. Let me go to a new board. And let's make up a vector. Let's say it's that long, starts there. Let's call it vector V. Vector V. And there's its rotation. And let's say we measure it, and it's, I don't know, it looks about, what does that look like? An inch long? Let's say it's 1 inch long. And let's say the angle is 30 degrees. Okay, so I'm just making one up here. So we've got a vector, and its magnitude is 1 inch. Its direction is positive 30 degrees, and it's kind of important to make sure that you talk about whether the direction you're talking about is a positive angle or a negative angle. Remember, negative angles rotate that way. That's a negative angle. Positive angles rotate this way. That's a positive angle. Okay? So that's how we talk about them. So when your problems are asking you, excuse me, to use a ruler and protractor, what you would do is you would measure the distance from there to there. That would be the magnitude or the length. And then you'd use the protractor to measure from there to there. And you might want to think about, I think for both of these, you could probably use a virtual ruler and a virtual protractor. There are apps for that on your phone if you want to do that, unless you have the physical ones there with you, but you can certainly use apps to do that. So that's just finding their magnitude and direction. So let's talk about the other part of this, which is to add and subtract vectors. Okay, so let's say we have two vectors, a vector v, and let's have another one here. It'll be a little bit longer, and it'll look like that, and that'll be vector u. Vector v and vector u are used quite a bit. And we know some stuff about these. We know how long vector v is. Let's say again it's 1 inch. And we know its direction. Let's say this is 35 degrees. I don't know, that looks sort of right. Maybe 40 degrees, maybe 45. It's hard to really tell. Now, for vector u, I could look at the angle that way as a negative angle, or I could look at the angle as a positive angle that way. Either way, I got to measure it first. Let's say it's 2 inches long. And if I'm looking at the positive angle, I don't know, let's say 150 degrees, because I'm going to say this is a negative 30 degrees there. Those are describing the same thing, just so you're aware, okay? And you're getting this again all with a protractor and ruler, and your problem asked in centimeters, and it still asks for it in degrees because most protractors don't come with radian measures, which is unfortunate, but hey, that's the world that we live in. So let's say I wanted to do vector v plus vector u, okay? And to do that, to add vectors, your thing, by the way, I know what your book says because I use the same book for my pre-calculus students. So your book gives you 2 methods. I'm only going to give you one because I think it's the easiest, the most straightforward, and it works really, really well. And that is the so-called tip to tail method. Okay. The tip to tail method just says draw your first vector, and I do mean first vector in order, so there's vector v, and then draw your second vector and put its tip on the other one's tail. Tip is the beginning, tail is the end, or maybe vice versa. I might be getting that mixed up. But either way, from beginning to end, and then put its beginning on the end of that one and redraw it with the same way. So this one, V, still has that angle of 35 degrees there, and U here still has the angle here of negative 30 degrees. Okay, so let me get rid of all that extra stuff there. But I wanted to show you that we're still using the same things. Okay, so there's vector V and vector U, and to get the sum of the two vectors, to add the two vectors, we start at the beginning of the first one and go to the end of the second one, and this then is the sum of the two, that is vector V plus U. Actually, maybe I should, no, I'll leave it that way. And so then what you would want to do, and I've sort of drawn this poorly because probably should have some better stuff, but let me use a different color to demonstrate something. Now this isn't quite on the x-axis. It has a tiny bit of an angle there. And so there's the x-axis. And what you would then want to know is you would want to measure, let me do it in blue here. Here's your new vector. And you would want to measure the angle from there to there. And that would be your magnitude and direction of your new vector. Okay? So that's adding vectors. And I hope that's fairly clear. If you want to do more than two together, you get two of them and then do a third one. But let's talk about subtracting vectors. Okay, how are we going to subtract two vectors? Well, let's have two vectors again. Let's say we have a V, and I'm going to be more careful about drawing the U. This time I'm going to draw it real extra long. So there's a different V and U. So remember that to add them, we just redrew them, tip to tail, and drew a new vector connecting the beginning of the first one to the end of the second one, and that became our new vector that was our two old vectors added together. Okay? So what if we wanted to do V minus U? Okay? Well, I want to remind you of something. I'll put in a box here. Reminder that 8 minus 5 is the same as 8 plus negative 5. And this is true for vectors also. V minus U is the same as V plus negative U. And what happens there is the negative changes the direction to the exact opposite direction. Okay? So if this U was on a coordinate system, then negative U would be up here. It would go in the exact opposite direction on the graphing system. Okay? So if you were going to draw it, you'd draw V the same way. Whoops, let me change where that is. You'd draw V the same way, but U would be the same length, but in the opposite direction, which is to say that instead of, so U has this angle to it, so the other one winds up having that angle to it, which, if you look, is 180 degrees away from it. And that's how you get the negative vectors for these. Okay? So then the new vector, so here's V, here's negative U. The new vector, oops, I didn't draw that very well. The new vector is still drawn from the beginning of the first one to the end of the last one. And so this is still V plus negative U, or V minus U. Okay? And then you do the same thing. You'd have to measure it with a protractor and a ruler. Okay, so that is how you add and subtract them. The scalar multiplication is really simple. If I wanted to do, so let me talk about scalar multiplication. If I wanted to do 3 times vector v, and if vector v looked like that, then 3 times vector v would be 3 times the length, and the direction would stay the same. So whatever that length is, it would get 3 times longer. Okay? So that should give you a pretty good idea on how to do these. The one thing that I'll say is do them, only put together 2. Put together 2, get an answer for it, use that new one, and then use that new one with the next 2. Okay? So that, I think, should be enough for you to do everything that you need to do in the page that you sent me. Let me remind you of some terms, or let you know about some terms. If you do this, if you put it inside of absolute value bars there, this asks for the magnitude of vector v. Okay, so it's asking for the length, which should make sense because the absolute value bars, right there, those absolute value bars, absolute value means the distance from 0, that is the length. So absolute value is asking you for a length, a distance. And the same thing here for the magnitude of a vector. We're asking you for its length, its distance from beginning to end. The other thing is, again, use this tip to tail method where you have your first vector and then your second vector attached to it, the tip to the tail, and then the new vector is from tip to tail, from beginning to end. Okay? By the way, the reason there are arrows on the end are not because they go on forever, but so that you know which way it goes, because vectors have a starting point and an ending point, and the arrow is always at the end point. Okay? I hope this helps. You can let me know if you need any more help. Thank you very much.